Hi everyone, welcome back to the channel. So today we have another problem and this is definitely going to give you some concepts. So let me explain the problem first. So we have a ring here and you can think of it like a hoop, and there are two beads of mass m, small m. Initially they are at the top. The entire hoop is frictionless of mass m and the radius is r. And this is standing vertically on the ground initially. So when we give a tiny kick to these two little beads, they start sliding down. And we need to find what is the smallest value of small m by m so that hoop will rise up off the ground at some time during the motion. And we need to also figure out at what theta, what angle, when the bead is making, let's say, at the center towards the vertical, what angle theta the hoop will bounce off. So this is the problem. Please go ahead and try this problem and let me know your solution, or if you have any question, you can always reach me through the email or you can leave a comment. Okay, so let's first draw some free body diagram and see what's going on. Okay, so if you see the bead here, okay, let's just consider this bead. Let's say at any point this bead is at angle theta. Okay, let's say this is the hoop. Okay, so this is the scenario. So what's going on here? The bead is sliding down. Okay, so if I just take the bead here, and then there is a normal force here, which is due to the slide on the bead. Okay, so if I take the entire hoop here, okay, so there is a normal force, and then there is a normal force on this side because of there are two hoops here, and then there is a weight, right? This is the scenario, and this normal force will keep changing direction as we go down the hoop, and you will see that after this point certainly the hoop cannot bounce because the normal force will act downwards, some component, and the mg is also downwards. This mg is mass of hoop. Okay, and if this is the scenario, and then there is a reaction force here, so this normal force, the opposite of this normal force, will act on the bead. The mass is also, and at this moment, let's say the velocity is v, acceleration is a. Okay, keep watching this video because I'll be solving this problem in two ways at different points and show you how to approach this problem in multiple ways, whichever is convenient to you. Okay, so initially, if we take this direction, let's say this direction as x and this as y. Okay, so fx equal to max, which will give me n plus small mg cos theta. This is theta, so this is also theta. Okay, and that should be equal to mv square by, let's say, r is, let's say, the radius. It's capital R, but doesn't matter. Now we can approach the second equation using two different methods. So first let's use the Newton law only. Fy equal to may, we get mg sine theta equal to ma. Therefore a equal to g sine theta, and a we can write v dv by, let's say in this direction, delta y, okay, dy equal to g sine theta. If you see this, if it goes further by angle delta theta, then this is delta y, and delta y is nothing but r delta theta. So therefore we can write v dv by r d theta equal to g sine theta, and v dv equal to gr sine theta d theta, 0 to theta and 0 to v. Okay, and that gives me v square equal to 2gr 1 minus cos theta, right? We can get this equation very easily using the energy conservation. Okay, since the external force is 0, so energy is conserved. Okay, I hope you get this. And then let's say it goes down by angle theta. So the total distance covered in downward direction is r1 minus cos theta. Hence this will be mg r1 minus cos theta equal to half mv square. And therefore v square is 2gr 1 minus cos theta. Okay, so same equation as this one. I just solved this for V using this because in many times the energy may not be conserved, and therefore you need to use this model, this approach. Let's compute n. So from 1 we have n equal to mv square by r minus mg cos theta. Okay, so we'll just replace v square with this. So this becomes 2 mg r1 minus cos theta minus mg cos theta, and r will get cancelled. Okay, so that means we have mg 2 minus 3 cos theta. Okay, so this is our n. Let's call this question 4. Okay. Now, if you analyze the forces on the hoop, you get 2n cos theta plus r equal to mg. Hence, therefore, r should be 0 if hoop bounces off. Okay. By the way, you can check here, n is only going to be positive if 2 minus 3 cos theta is positive. Therefore, cos theta must be less than 2 by 3, which is, it must be less than 90 degree if the hoop has to bounce, which is very clear from our assumption also. Okay. Now, so this one, we can simply say 2n cos theta is mg. We can put n from here. So 2n is mg 2 minus 3 cos theta equal to mg, bigger capital mg. Okay. So we can write this whole thing as 2m by m 2 minus 3 cos theta equal to 1, and that gives me equation 6m by m cos square theta minus 4m by m cos theta plus 1 equal to 0. So the determinant here should be real, and therefore 4m by m whole square minus 6m by m to 1 should be greater than 0, and that gives me 4m by m 4m small m by m minus 6 greater than 0, and therefore m by n should be greater than 3 by 2. So this is the condition, the answer. Okay, now so what is the angle theta here and for this condition? So we can write cos theta is 4m by m divided by 6m by m into 2. So that should be equal to 4 by 12. Therefore, cos theta is 1 by 3. So at this theta, if m by m is 3 by 2, the hoop will bounce. But this is the minimum condition, that m by m should be greater than or equal to 3 by 2. Okay. If it is heavier, then the hoop will bounce much before this angle. But this is the maximum angle, which is definitely less than 2 by 3, which we figured out here. Okay. Now let's try to approach this problem in a different way. Okay, the last part from here. Okay. So if you see 2n cos theta that we have, the force that is acting upwards, 2n cos theta. So at certain point theta, F should be maximum, right? This force should be maximum, F max for certain theta. And that we can get using dF by d theta equal to 0. Okay, so we do that. Df by d theta equal to, we replace the n with this expression. So mg 2 minus 3 cos theta, okay, d by d theta of this whole thing. And then we get minus 2 mg 2 minus 3 cos theta sin theta plus 2 mg cos theta 3 sin theta. This has minus 2 sin theta 2 minus 3 cos theta plus 6 sin theta cos theta mg outside. And let's put this to 0. Therefore, if we take sin theta, 2 sin theta outside, it becomes 3 cos theta, okay, minus 2 plus 3 cos theta equal to 0. Okay. Since theta can't be 0, this should be greater than 0. Therefore, 6 cos theta is 2. That implies cos theta is 1 by 3. Okay, so using this method, we get the theta first. Same, cos theta is 1 by 3. And therefore, F max is 2. It's 2n cos theta, right? So this is 2 by 3n. And what is n? N is nothing but mg, this one. So this is mg 2 minus 3 into cos theta 1 by 3. That is mg. So F max is 2 by 3 mg. And this must be greater than or equal to the mass of the hoop, the weight that it needs to lift. And therefore, m by m should be greater than or equal to 3 by 2. Okay. This is also the answer. Same answer as this. Okay. So I solved this problem using different methods so that you get the insights, you get the concepts. Whichever seems comfortable to you, you should use that in the examination or to solve such problems. I hope you enjoyed solving this problem and also learned few things. Please do subscribe and like this video. Go to our channel. There are multiple problems there in different areas in the mechanics right now, which will definitely enhance your concepts to tackle IIT JEE advanced domain problems a lot more comfortable way. Thank you very much. Thanks for watching. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.